Lesson 8.2 is on completing the square. The goal of completing the square is to create a perfect square trinomial so that we can use the square root method, and that's what we learned in lesson 8.1. We complete the square with trinomials that aren't factorable. So before, when we would try and solve something, we had to use zero product property. If we couldn't factor it, we would write prime. Now what we can do is create a perfect square trinomial so that we can use square root method. So the first thing that we're going to review is how to check for perfect square trinomials. Now remember, in a trinomial, you have to have all three terms. The first term is perfect, so is x squared perfect? It is. And the square root of that is x. Then the constant term is perfect. 16 is also perfect. The square root of that is 4. And the linear term needs to be 2 times the product of those square roots. And so 2 times x times 4 is 8x. Therefore, we know that this is a perfect square trinomial. We put in the terms that are going to be part of the binomial, and then the sign follows that middle one, and then we square it. So what do we do when we need to create a perfect square trinomial? So if we don't have a perfect square trinomial, what we're going to do is create it so that we can use the square root method. But how do you do that? Well, what we're going to do is we're going to use the quadratic and linear terms. And then we're going to create a new constant term that will give us our perfect square trinomial. How do we do that? Well, we know that middle term was 2 times the product of the square roots of the outer terms. So that's 2 times, and then the square root of this one is x. That's the first part. But I'm missing the square root of that one. And so this is the one that we don't know just yet. I'll put a question mark. But I have 2x accounted for. So if I divide my current middle term, right? So my current middle term is 12x, and I divide that by 2x, I'm going to get the square root of what was left. I'm going to get what was this question mark. And so 12x divided by 2x is 6. So this question mark had to have been a 6. So 2 times x times 6 equals 12x. And that's where that middle term came from. Well, this, remember, is the square root of the constant term. And so what results in 6 when I take its square root? That would be 36. And I can find that just by squaring the 6. So 36 had to be the thing that went in here. So what do we do? Well, we're going to take the value of b. And remember, b is the coefficient to the linear term. We're going to divide it by 2, right? And then we're going to square it. And that will give us the new constant term. Okay, let's practice that. Let's look at some simple examples. In all of these, the leading coefficient, or the coefficient on the quadratic term, is going to be 1. And so we really only have to focus on the b to complete the square. Let's start with this first example. So I have x squared plus 4x, and I need the constant term that makes this a perfect square. What's the value of b? It's 4. So I'm going to take value of b, divide it by 2, and square it. You want to actually multiply by a half, because as you'll see, when we get to odd integers or fractions, it's a little bit easier to deal with when we are multiplying by half as opposed to dividing by 2. 4 times a half is 2, and 2 squared is 4. And so the value that completes the perfect square trinomial here would be 4. And you can double check that. The square root of x is, the square root of x squared is x. The square root of 4 is 2. Is this middle term 2 times the product of these square roots? X times 2 is 2x times 2 is 4. Yes, it is. Sign follows the middle, and it's a perfect square trinomial I created. Now let's look at another example. Again, we are finding the constant term that creates it. The current value of b is negative 6. So I'm going to take half of negative 6 and square it. Half of negative 6 is negative 3 squared is 9. And so 9 is the value that completes the perfect square trinomial. Notice in both of these, the 4 and the 9, these first two examples, they're both positive. That always happens in perfect square trinomials anyway, but we're squaring either a negative or a positive, so we're always resulting in a positive. You can check this one out as well. Let's look at this next one. Again, I need to create a constant term that creates my perfect square trinomial. What's the current value of b? Well, that's -5, so I need to take half of -5 and square it. -5 times a half is just -5 halves. Fractions are very easy to multiply. Squared, and squaring fractions is also easy. -5 squared is 25, and 2 squared is 4. And so the value that completes the perfect square trinomial is 25/4. You can leave it just like this. That's perfectly fine. Do not turn that into a mixed number. As we get into equation solving with this, you don't want it to be a mixed number. Let's check out our last one. Again, we need a term to be added in here, a constant term. My current value of b is 3/4, so I need to take half of it and square it. 3/4 times a half is 3/8. 3/8 squared is 9/64. So the value that completes my perfect square trinomial is 9/64. What are we going to do when the leading coefficient or the coefficient on the quadratic term is something other than 1? Here, we need to actually make it 1 so that it's easy to deal with. We're going to use GCFs, or the idea of dividing out, in order to do that. Now, we're only talking about the coefficient here. So while, if you look at these examples, they will have a variable in common as well, we don't care about that. We are trying to complete a perfect square trinomial, so we don't want to also factor out the variable. You'll see what I mean in just a second. So looking at this first example, my leading coefficient is -2. And so I need to make that a 1, so I'm going to divide out -2. -2 divided by -2 is 1. That leaves me with x squared plus 4x inside the parentheses. But what I need to do is, of course, complete the perfect square trinomial. So I'm going to give myself a little bit of space so that I can do that. Now, looking inside the parentheses, what do I have? My value of b is 4, so I need to take half of that and square it. Half of 4 is 2. 2 squared is 4. And so when I add my 4 in here, I've now completed the perfect square trinomial. Looking at our second example, the leading coefficient, or the coefficient in the quadratic term, is 3. And so I need to factor out a 3 so that I can make that coefficient 1. So I have 1x squared plus, this is a little ugly, but not too difficult to deal with, 5/3 x, so 5 divided by 3 is just 5/3. Give myself a little bit of space to complete the perfect square trinomial. Now, inside those parentheses, I have a b, 5/3, that I can divide by 2 pretty easily and square. 5/3 times a half is 5/6, and 5/6 squared is 25/36. And that is the value that completes my perfect square trinomial. Let's look at how to complete the square to solve an equation. We've been practicing with expressions. Now we're going to see the rules for solving an equation by completing the square. The very first step in this is to isolate the quadratic and linear terms. Remember, we're trying to create a brand new constant term that makes a perfect square trinomial. So we need to move the current constant term to the other side of the equation. That leaves me with x squared plus 8x. Give myself a little bit of space to complete the perfect square trinomial, equals -12. Okay, now I need to divide out a if the value of the leading coefficient isn't 1 already. It is, so I don't have to do any work here. Step 3 is to complete the perfect square trinomial by taking half of b and squaring it. My current value of b is 8, and 8 divided by 2 squared is 4 squared, and 4 squared is 16. So 16 is my new term that completes the square, and I'm just going to add that in right there. However, now we're dealing with an equation, And in order to be fair, if I add in 16 to the left, I have to stay balanced and also add in 16 to the right. That allows me to now simplify my perfect square trinomial that I created on the left, which will just be x plus 4 quantity squared, and then simplify the terms on the right. That would be a positive 4. We created this perfect square trinomial, x squared plus 8x plus 16. So factoring it should be very simple. Take the square root of the first term, and that goes there, and the square root of the second term, of the last term, and that goes there, and then the sign is what follows the middle term. I now have square root method set up, and I can very easily solve this binomial squared set equal to 4. I take the square root of both sides. The square and the square root cancel out. Whenever I take the square root, I make sure I add the plus or minus, and I'm left with x plus 4 equals plus or minus 2. That gives me two equations. X plus 4 equals positive 2, and x plus 4 equals negative 2. By using simple inverse operations, subtracting 4 from both sides, I'm left with x equals negative 2 and x equals negative 6. I would then take these two answers and plug them back in and double check my work. And just to show you that we get the exact same thing, this one I picked first is actually factorable. If I had x squared plus 8x plus 12 equals 0, I really could use zero product property. Find all the factors of 12. That's 1, 12, 2, 6, 3, and 4. 2 and 6 can create an 8, so that's x plus 6 times x plus 2 equals 0. And when I use zero product property and solve for this, I get x equals negative 6 and negative 2. So you can see we get the exact same answers, just with a new method. This method, though, is really helpful when you have something that's not factorable, as we'll see in the next examples. Okay, let's complete the square with a value of a being something other than 1. Step number 1, isolate the quadratic and linear terms. So what I'm going to need to do is to add 4x to both sides, and at the same time I'm going to go ahead and add 2 to both sides, so I can move the current constant term to the right side and everything else to the left. That leaves me with 2x squared plus 4x, I'm going to give myself a little bit of space to work with, equals positive 2. Step 2, divide out a if that's not already done for us. It isn't. And so I'm going to be very careful and use the division property of equality and divide every term through by a. Now I have x squared plus 2x, again give myself a little bit of space, equals 1. Now I'm ready to complete the perfect square trinomial. My current value of b is 2, so I'm going to take half of b and square it. Half of 2 is 1, and 1 squared is 1. And so that's my new constant term that I'm adding in. But I have to be fair using the property of equality, and if I add it in on the left, I also have to add it in on the right. Now we're ready to simplify. We created this perfect square trinomial, so we know exactly what it's going to factor to. X plus 1 quantity squared equals 2. I've now isolated the binomial squared, and I can use the square root method to solve. Take the square root of both sides. When I put the square root, I also have to add the plus or minus. The square and the square root cancel out, leaving me with x plus 1 on the left and plus or minus the square root of 2 on the right. I subtract 1 from both sides, and I'm left with x equals negative 1 plus or minus the square root of 2 for both of my answers. You're now ready to try some of these on your own. Go ahead and pause, write these two down. If you need to go back and look at the steps for solving these, you can do so. When you come back from pausing, you'll see the solutions for it with the, and I'll show each step with it. Your next two examples, pause now. And your last two examples. We'll discuss this more in class.